Hello, welcome to my math blog. Today we're going to be doing abstract algebra, and I'm going to answer the question, find the number of partitions of a set having two elements. So I'm not going to go over what a set is or what elements are. I'm just going to jump right into it. So I'm assuming a little bit of knowledge about set theory, basic set theory. So the first thing that I like to do when I'm trying to solve a problem in abstract algebra is to figure out what the problem is asking me and then what the components of the problem mean. So this problem is asking me about the number of partitions of a set. So I'm going to have a set. I know what a set is. It's just a collection of objects. I guess I said I wasn't going to say what that is, but I did. And this set has two elements, so it's not empty. It's a non-empty set. So I need to know exactly what is a partition. So if I look, I can find this definition. A partition of a set S. So if you are kind of new to abstract algebra, when it says a set S, we just mean that if we have any arbitrary set, we can call it S. So, oh, that's a cat. Okay, sorry. So a partition of a set S is a collection of non-empty subsets of S such that every element of S is in exactly one of the subsets. So it sounds so far, if you take a partition of a set S, you take the subsets of S and put every element that's in S in exactly one of these subsets. Then you call the subsets cells of the partition. Okay, so that may just seem like a lot of words. So let's take a look at maybe what one would look like if we could draw it. So this is purely an abstract model. Let's say I have this set here, S, and S is this thing here. And it has two elements. It has a blue dot and a black dot. Okay, so here's my set S. Now, well, I don't want those yet. Those are too early. Okay, so like I said, this is just an abstract model to kind of help understand. So here's my set S. It contains two elements. If you wanted to, you could say that the black dot is a subset of S by itself, and the blue dot could be a subset of S. Both the black and blue dot could be a subset of S, and then also the empty set would be a subset of S. But we want to know about partitions. So if we were to make a subset, okay, so the partition takes the subsets and arranges them so that each element is in exactly one of the subsets. So one way for me to partition this is to do really nothing to it. So I have the subset of both elements, so that a partition of S, one possible partition of S would just be the subset of S itself, the blue and the black dot. Another possible partition would be the subset that it contains. So now I'm going to, actually, I'm going to do it like this. So let's say now I take and I split up the two, and I've got black dot over here, blue dot over there. So now I've got a partition that has taken the subsets and assigned to each of them, so then now this becomes a subset and this becomes a subset. So now I've got a subset here and a subset here, and this collection of subsets is a partition itself. So then in this side I've got the one element, and this side I've got one element, and so each of the elements is in exactly one subset. just as it was the first time when I just had the subset of S was just the subset, was just S itself. So that's a partition as well. Now then, let's look at, say, a more concrete, I guess, example. So we've looked at the definition. Now we're going to look, and then we looked at what it may look if I could graphically draw it. Now let's look at another way to look at it. So let's say S is the set of elements A and B. So I want to partition this set, and I want to find all the possible, I want to find the number of partitions that I could possibly have. So let's see. Like I said before, I could take the subset AB, and that is one partition. Okay? So what I've done, my partition, you can think of my partition as these outside brackets. Inside that is the subset, the way I have arranged the subsets so that it is a partition. Alright, and then the other way that I can partition this set, so I'm going to use that to denote my partition. So now I can take this subset here and arrange them as such. Okay, so now as you can see that it fits by the definition. Each element of S is in exactly one subset here of this part, and the subset is in the partition. And then here, each element is in exactly one subset in that partition. So there are two ways to partition the set having two elements. Okay, I hope that helps. Don't forget, if you like, you can send your math problems to mathproblemsolvednow@gmail.com, and I could possibly make a tutorial for you and post it on my blog.